Well, sometimes I get asked the question, is there a wall out there that says the end of the universe, do not pass this point? Well, if there is a wall, then what lies on the other side of the wall? And is the universe infinite until you hit a second wall?
Just how big is the universe? That might sound like an easy question, but the real answer is far from simple. The universe doesn't just extend beyond what we can see. It goes far past what we can even imagine.
There are a lot of things about the universe that I find it almost impossible to imagine. Well, actually impossible to imagine. One, just the size and scale of it. I mean, in the piece of the universe we can see, there are something like, roughly, 2 trillion galaxies. We haven't counted them all, but that's an estimate based on surveys of the local universe. 2 trillion, 2,000 billion galaxies. And each galaxy is, let's say, around the size of the Milky Way. Some are bigger, some are smaller, but the Milky Way has 400 billion stars in it. It takes light over 100,000 years to cross a galaxy. And there are 2 trillion of them in the piece of the universe we can see. And we're very sure that that piece that we can see is a small bit of what may be an infinite universe beyond. We don't know, actually. And I always say, don't get worried about that, because nobody can picture it. It is impossible to visualize the scale of the universe. So that's the first thing. Right? I could then list a lot of more things, but we'll stop there for now. But just the size and scale of it, I think, is beyond imagination.
Let's begin with what we do understand. The part of the universe we can actually observe is around 93 billion light-years wide. That means in every direction we look, we can see about 46.5 billion light-years out. This isn't just because of the universe's age. Space itself has been expanding throughout the 13.8 billion years since the Big Bang. And this is where things already start to get strange. You might wonder, if the universe is 13.8 billion years old, shouldn't we only see 13.8 billion light-years in any direction? But that's not the case. The space that light traveled through has been stretching the entire time. So the actual distance to many of the galaxies we see is much greater than 13.8 billion light-years. In fact, some of those galaxies, the ones just barely visible at the edge of what we can detect, are now over 46 billion light-years away. And they're still moving farther. So even now, the numbers start to go beyond what feels logical. But this is only the beginning. That 93 billion light-years, that's only the observable universe, the part where light has had enough time to reach us. Think of standing in a foggy field at night with a flashlight. You can only see within that beam of light, but the field stretches much farther in all directions. That's how our view of the universe works. Cosmologists now estimate that the full universe could be at least 250 times larger than the part we can observe. That's not 250 light-years. That's 250 multiplied by 93 billion light-years. It's a number too massive for our brains to picture, a size that makes no practical sense. Even if you gathered every single star we can observe, roughly 100 billion of them, it would barely make a dent in what might be out there. But it gets even more mind-bending. Some scientists think the universe may be infinite, not just really large, not just much bigger than we can detect, actually infinite. That would mean no outer edge, no end, no outside, just endless space in all directions. And if the universe is truly infinite, then we run into some very strange consequences. In an infinite space, there are only so many possible ways to arrange particles, so eventually, every possible arrangement would repeat. That includes the arrangement that makes up you. Somewhere unimaginably distant, there could be another version of you, living on a planet almost exactly like Earth, maybe with a few atoms arranged differently, or maybe no differences at all. This isn't science fiction. It's just what happens when you apply basic math to infinity. Now think about this. When you look at the night sky, the light you see has been traveling for millions or even billions of years. Each star is a signal from the past. But since the universe is not just expanding, it's accelerating in that expansion. Some galaxies are already moving away from us faster than light itself, and that means their light will never reach us. Not now, not in the future. Ever. With every passing second, more of the universe slips beyond our ability to ever observe. We're not just facing enormous distances. We're surrounded by parts of the universe we'll never be able to see. In the distant future, billions of years from now, entire galaxies will disappear from view. Not because they'll stop existing, but because their light will never reach us again. The observable limit, the cosmic horizon, isn't shrinking in size, but it is shrinking in what we can access. The longer we wait, the less of the universe we'll ever be able to explore or understand. Now imagine this. Everything we've talked about, the stars, galaxies, nebulae, cosmic radiation, everything we call the universe, might be only one small piece of something far bigger, a multiverse. Some modern physics theories suggest that our universe is just one bubble among countless others. Each bubble would have its own space, its own time, its own physical rules, maybe even different dimensions or constants. Some of these universes might never form stars or galaxies. Others could be filled entirely with black holes. Some might contain forms of matter or energy that we can't even describe, and we might never be able to reach them. Still, just considering their existence changes how we think about the size of everything. If universes are constantly forming, each from its own Big Bang, then size becomes meaningless in the way we usually understand it. The universe isn't just large, it's something that breaks our entire idea of what large even means. Let's bring it back to something smaller. If you hold out your hand and point at a tiny patch of sky, about the size of a grain of sand at arm's length, and zoom in on that spot using the Hubble Space Telescope, you'd see thousands of galaxies, not stars, entire galaxies, each filled with hundreds of billions of stars, all in just that tiny spot. Now imagine multiplying that all across the sky. Suddenly, our Milky Way, with its estimated 100 to 400 billion stars, is just a single drop in a vast cosmic ocean. And yet, even with all that, the universe is mostly empty. Space is dominated by vacuum, cold, and darkness. The distances between stars are so massive that if the sun were the size of a basketball, the next closest star would be thousands of kilometers away. Its scale is built on space, silence, and separation. So how big is the universe, really? It's bigger than what we can picture, bigger than what we can calculate, bigger than what our words can describe. It's not just about how far things are. It's about the scale of the idea itself. It's about realizing that everything you know, your life, your species, your planet, is only a tiny part of a much bigger picture. We're floating in something so vast that we might never know where it ends. And yet, despite all that distance, here you are, listening, thinking. In its own strange way, that puts you at the center of something important. Not the center of space itself, but the center of awareness. You might never cross the universe physically. You may never reach its farthest edge. But by simply asking how big it is, you've already done something light itself cannot. The truth is, the universe doesn't really have an edge, not because it stretches on forever in a straight line, but because the idea of an edge doesn't work the way we expect. Let's take a moment to understand that. If the universe really is infinite, with no boundary at all, then no matter how far you go, there's always more. There's no wall to hit, no outer border, just space continuing endlessly. But what if that's not the case? What if the universe has limits, but no edges? That might sound strange, but there's a way to picture it. Think of an ant walking on the surface of a balloon. The ant can keep moving forward forever and never reach a wall or fall off. It's walking across a surface that curves and loops back around. There's only so much area, so it's limited, but it doesn't have an edge. Now take that idea and imagine it in 3 dimensions. That's what some scientists think space might be like, a kind of 3-dimensional curved space. It could be finite, but without borders, without an edge, and without a center. If you could travel far enough in one direction for an unimaginable amount of time, you might actually return to where you started. That's called a closed universe. But there are other theories too. Some scientists think the universe could be open, curved outward like a saddle and expanding without end. Others believe it's flat, which is what current data seems to show. In this case, space doesn't bend much at all on large scales and just goes on endlessly in every direction. So the shape of the universe isn't just a question for math nerds. It affects how space behaves, how light travels, how the universe started, and how it might eventually end. And here's another thing to think about. We may never fully know the size of the universe because of something known as the cosmic light horizon. That's the farthest distance light has been able to travel since the Big Bang. Beyond that, we have no direct access. There could be hundreds of times more universe out there, or that might be all there is. We simply don't know. Thanks to cosmic inflation, a rapid burst of expansion, right after the Big Bang, the universe could be so massive that anything beyond our small visible part will always be out of reach. It's like sitting in a small boat surrounded by fog. You can only see what's nearby, but the waves and the movement around you hint that the ocean is much bigger than what your eyes can catch. So how do scientists even begin to study something that could be infinite? They look for signs in the sky. They examine the cosmic microwave background, the leftover glow from the Big Bang, for clues like repeating patterns or tiny distortions that might show if space curves or loops. They also study how galaxies are spread out, how fast space is expanding, and whether that expansion is changing speed. Right now, all that evidence points to a universe that appears very flat, supporting the idea that it could go on forever. But forever may depend on how we choose to look at it. There's one more question that adds another layer. What is the universe expanding into? And the answer is nothing. Not because there's empty space waiting out there, but because space itself is growing. It's not moving into something else. It's stretching, creating more space as it goes. There's no outside of the universe. The expansion is happening within space itself. As that happens, galaxies that aren't held together by gravity are drifting farther apart. That expansion is speeding up too, driven by a force we call dark energy. We still don't know what dark energy actually is, but we do know it makes up about 70% of all the energy in the universe, and it's causing space to grow faster every second. That means the galaxies we can see today won't always be visible. Eventually, they'll disappear from view forever. The universe we see right now won't stay the same. It's a temporary snapshot, just a small piece of a much bigger picture. This moment, right now, is special. It's a time when galaxies still fill the night sky, when we can still receive light from billions of years ago. People in the distant future may not have that chance. Someday, the universe may become so vast and so empty that all the stars we see today will be gone. A dark sky, a quiet one. But right now, we can see it. Right now, we can ask questions. We know the universe is huge, not just in size, but in how much it means, in how much we don't yet understand, in how much potential it holds. So, how big is it really? Big enough that we may never find its edge. Big enough that there might not be one. Big enough to hold not only space and time, but the ability to wonder. For a species like ours to look into the unknown and say, "I see you." That alone might be the most powerful fact of all. When you ask how big the universe is, you're also asking how small we are, how far our knowledge can reach, and maybe more than anything, how far our imagination can take us. Think about that scale for a second. Light, the fastest thing we know, takes 8 minutes to reach us from the sun. It takes 4 years to get to the closest star. It takes over 100,000 years to cross our galaxy. And the observable universe, that's 93 billion light years across. That means even if you could travel at light speed, your entire life wouldn't take you beyond the outskirts of our local neighborhood in space. We're surrounded by places we may never reach, and yet, using math, light, and time, we can still explore them. We can draw maps of what we can't touch. We can uncover the history of galaxies that formed long before Earth did. In a way, our minds travel farther than any spacecraft ever could. And that leads to one of the most incredible truths of all. The universe isn't just big in space, it's big in time. The universe is about 13.8 billion years old, and that number isn't just a fact, it's part of a story. Every atom in your body came from stars that lived and died before the sun was born. You are made of ancient matter. You're built from the universe's past. So when you stare up at the night sky, you're not only looking across great distances, you're also looking back in time. Each star is a message from the past. Every beam of light is ancient. Some of it began its journey before Earth even existed. Now, if that isn't already a lot to take in, think about this. Most of the universe is completely invisible to us. We only get to see about 5%. The part made up of atoms, the matter that reflects or gives off light. The rest is made up of dark matter and dark energy. These things can't be seen or touched, yet their presence is felt everywhere. They hold galaxies in place, shape the universe, and even drive its rapid expansion. It's like trying to read a book where most of the pages are blacked out. You catch pieces of the plot and sense the direction, but the full story remains hidden. And still, we keep reading. We keep watching the skies. We keep asking questions. We build telescopes that can catch a single photon that's been traveling since the beginning of time. We listen for signals. We scan for exoplanets. We look for patterns in what seems like noise, because deep down, something tells us the universe wants to be understood. Not like a person, not like a god, but as a natural process, as a reality that's constantly changing and includes you right now as you're listening and imagining. So how big is the universe, really? It's larger than space as we know it. It's beyond time. It's more massive than anything we can use to measure it. Its size is tied to our curiosity, how far we're willing to go into the unknown, even if we never physically reach it. And maybe that's the most important measurement, because even in a universe with around 2 trillion galaxies across nearly 14 billion years of time, on a small planet circling an average star, you're here asking questions. You're thinking about it. That means the universe, as massive as it is, has produced something that can think about itself. Let me know when you're ready to keep going. We can dig further into the structure of space, the strange nature of dark energy, or where the universe meets quantum physics. The journey isn't over. In fact, the map of the universe is still being made. Not with pencils or satellites, but with the questions we ask. And each time we find an answer, it leads to even more questions. That's how a universe this huge works. It doesn't just hide mysteries, it creates new ones. It's not still or silent. It's active, moving, always changing. And as we grow and learn, our understanding of it does too. Take the theory of cosmic inflation. It suggests that in the tiniest fraction of a second after the Big Bang, the universe expanded faster than the speed of light. Not just fast, beyond what we can fully grasp. This sudden expansion smoothed out space and helped galaxies form. It also explains why the leftover glow from the Big Bang, the cosmic microwave background, looks almost identical in every direction. But what triggered that expansion? And what existed before it? We don't know. Maybe we never will. But even that uncertainty tells us something. It hints that the birth of time and space might not have been the true beginning. There could be deeper levels beyond the Big Bang, fields, forces, quantum processes that gave rise not to one universe, but possibly many. So when we ask about the size of our universe, we're also asking, is this the only one? Is there a boundary where different physics take over? Could the multiverse be a natural result of cosmic inflation? If that's the case, then even the idea of infinity starts to feel small. But here's the surprising part. For all the distance, time and emptiness between galaxies, the part that truly matters is right here. Because the size of the universe only means something because there's something inside it that can ask about it. That something is you. You're not just another object drifting through space. You are a mind that thinks, a rare form of awareness. You don't just exist in the universe, you reflect it. You carry its atoms. You're shaped by its forces. Your thoughts mirror its structure. In the connections of your brain, in your curiosity. That means the true size of the universe can also be measured in wonder. Yes, the galaxies, black holes, and gravitational waves are extraordinary. But the most surprising part is that we can understand even a small part of them and feel awe from it. The question, how big is the universe, doesn't have a final answer. It expands as we improve our technology. Every time we send a new spacecraft deeper into the void, every time we look at the afterglow of the Big Bang or simulate what the universe was like in its first tiny moments, it grows. With every theory we build and every one we revise, with every mystery we solve and every one we uncover. Right now, the James Webb Space Telescope is revealing sights we've never seen, galaxies from just a few 100 million years after the Big Bang, massive structures that don't fit our current understanding, new stars forming behind cosmic clouds that used to block our view, clues about dark matter, alien worlds, and the chemistry of the oldest light in the cosmos. And we're still at the beginning. Every new tool shows us more, and each discovery opens another doorway. So maybe the size of the universe isn't really about how far it stretches. Maybe it's about how much it can hold. Galaxies, black holes, gravity, chaos, but also memory, imagination, hope, and love. All of it is part of the universe, just like you are. And maybe the biggest twist of all is this. The universe is so vast, and yet it made something small enough to ask how big it is, and bold enough to never stop wondering. So keep asking, because no matter how wide it stretches, how fast it moves, or how tiny you feel within it, the universe is not done. Not in size, not in discovery, not in meaning. And neither are you. Think about how far we've come already. Just a few hundred years ago, we thought Earth was the center of it all. The stars were tiny lights on a dome. The universe was small, fixed, knowable. But then we started to observe, to measure, to question. We built telescopes. We tracked the motions of planets. We found galaxies. We watched them move away from us and realized the universe is expanding. That single discovery changed everything. It told us we're not at the center. It told us space itself can stretch. It told us there was a beginning. And that beginning still echoes today. The cosmic microwave background, faint radiation left over from the Big Bang, fills all of space. We can detect it with instruments, map its tiny temperature differences, and learn about what the universe looked like when it was only 380,000 years old. That light has been traveling for nearly 14 billion years, and now it hits our detectors and becomes data, becomes insight. That's what the universe gives us, a story told in light, if we're willing to listen. And there's still so much we don't understand. We don't know what dark matter is. We don't know what dark energy is. We don't know why the expansion of the universe is accelerating. We don't know if time itself is a fundamental thing or an emergent property. But we keep going. We keep searching, building models, running simulations, launching satellites. Because every answer leads to a better question. What if we're just scratching the surface of what reality is? What if dimensions beyond the three we live in are curled up, invisible to us, but still affecting everything? What if the entire universe is a projection from a lower dimensional boundary, like a three-dimensional object casting a shadow on a two-dimensional wall? These aren't just ideas from science fiction. These are real theories explored by physicists, tested by experiment, limited only by the reach of our instruments and the scope of our imagination. The Large Hadron Collider lets us study particles smaller than atoms, smashing protons together at near-light speeds to peel back the structure of matter itself. Space telescopes like James Webb and Hubble let us look billions of light years away and billions of years into the past. Radio arrays listen for signals that might carry the fingerprints of life, of intelligence, of something that shares the universe with us. And all of this points back to a simple truth. Asking questions is what makes us part of the universe, not separate from it, not above it, but deeply inside it. We're not outsiders looking in. We are the universe becoming aware of itself. The atoms in your body were forged in stars. The iron in your blood came from supernova explosions. The calcium in your bones, the oxygen in your lungs, the carbon in your brain, all of it was born in cosmic events that took place long before Earth existed. You are not just in the universe. You are the universe. Just as much as a star, just as much as a galaxy. That perspective changes things. It makes our problems feel smaller, but not meaningless. It makes our time feel brief, but not wasted. Because in a universe this old, this wide, this complex, the fact that we get even one moment to be aware of it, to observe, to think, to wonder, is already extraordinary. And that's why we keep exploring. Not because we think we'll ever understand it all, but because every layer we peel back tells us something not just about the cosmos, but about ourselves. It reminds us that curiosity is not a luxury. It's a survival tool. It's the engine that moves civilization forward. It's what got us out of caves, onto ships, into the sky, and eventually into space. So what comes next? Missions to Europa and Enceladus, looking for signs of life beneath layers of ice. Telescopes that can image Earth-like planets around other stars. Instruments sensitive enough to detect gravitational waves from colliding black holes, or maybe even signals from the birth of the universe itself. We might find new laws of physics. We might find proof that life exists elsewhere. Or we might find nothing but silence. But even silence speaks. Even silence tells us something real. Because every time we reach, even if we don't grab hold of an answer, we stretch the limits of what we're capable of. We expand the edge of the known. We light a new candle in the dark. And that's the point. The universe may never give us every answer, but it gives us the space to ask. It gives us the conditions to exist, to grow, to question. It gives us time, however short. It gives us possibility. And if there is meaning anywhere in all of this, across the void, between the galaxies, inside the atoms, maybe it's this, that asking the question is enough. Thanks for watching, and we will see you in the next video.